Video here on the Raven flow valves that we run in our trucks. This valve controls the flow in the system. The computer will send a signal to this valve and tell it whether to open or close to cause more or less fluid to flow through the system. It's a fairly simple device. There's an electric motor in here. We're going to tear into that and take a look at it. And it's got a butterfly valve down inside of it here. This one here is labeled bad ? Which means somebody had taken it off from a truck, suspected to be bad, and they don't know for sure, I guess, is what that's what I would interpret that to mean. So we're going to play with it a little bit here right now. So they're calling this a standard valve, and it's just a 12-volt motor that opens and closes this butterfly valve. So in this case, the connector has been cut off the end of it. Normally there's a connector on it that looks like this, and what we do is literally just put power on one side and ground on the other, and we should see the valve move. So up here I've got a 12-volt battery sitting up here on the bench, and we can test it this way. So to test this particular valve, what I'm going to do is I am just going to put 12 volts of positive to one lead and negative to the other, and upon that I should hear the motor turning, and I should be able to look down here and see the valve close. You probably can even feel the motor turning if you hang on to it, and once it closes all the way, it'll stop. Now if I take these terminals and reverse them, and that's what the computer does to cause this to open and close, is it reverses the polarity on this, and it causes the motor to spin in the opposite direction. And here we see the valve opening up. These valves do not open all the way. It's going to stop at what to you is going to look like too far closed, but that is normal. That right there is its stopping position, and that is typically what I see for stopped valves. They stop about there. So now sometimes just because you can see the valve do this doesn't necessarily mean that the valve is strong enough to close against water pressure. So we'll have times that the valve becomes weak, where it doesn't actually stop working, it just becomes weak and it doesn't have enough power to hold the valve shut. And what happens is the water pressure pushing against the valve actually causes the valve to stay open and it won't close down. You'll see that in applications where you cannot get the rate with one small boom. You can't get the rate to come down as low as you need it to. Sometimes just lowering the pump pressure can help that. So, all right. So checking that valve is working correctly, so it does open and close. So I would call it a good valve, although it may be a weak valve, and I have not been able to determine that yet. We have not done enough to determine that. So here's another example of another valve with the plug still on it. So in this case, I can put my positive terminal on here, my negative terminal on here, and I'm going to watch for the motor to move, and I do not see it moving and I don't feel it moving. So we can try reversing that, and I get the same result, which tells me that this valve is not working. Okay, so that's how you would test this. Now I'm going to go into an advanced level. So if you were just watching this video to just learn how to test the valve, you can stop watching here. If you are the individual that wants to know more, we're going to dive into this valve and see what it's made of. So in this particular case, I've already disassembled this once, so some of the screws are loose. There's a little dust cap here on top. When I take these screws out, I can pull the dust cap off, and what we see here is just an electric motor stacked on top of a gear reduction. And you can see my wires come into the bottom of the valve, and then they run up the side and go right to the motor. Now, I could also test this by clipping my leads right here on the motor. And you can see that the valve is turning when I do that. Okay? Now when I do it here...
These don't go straight up though, there's a circuit board under it.
Okay. I know that. You're just a cameraman that can't even
directions.
So when I'm doing this, the valve is not going to stop where it's supposed to, because, as my lovely assistant already mentioned, underneath this motor, well, first, let's cover this part. So here's what it looks like. Sometimes what you'll see is water leaking out here. And if you pull this off, there's actually a seal. There's an O-ring down inside here that runs on this that seals this motor area from the valve. But now that we've pulled the motor off, I can actually take the butterfly out and you can see what the butterfly does. So the butterfly just slides on that shaft, and when the motor turns, it opens and closes, and then this part right here seals on that seal right down there. So if we're getting water coming out between this seal, that water is coming up from that O-ring. Possibly you can take it apart, replace the O-ring. We typically haven't. It doesn't happen very often. Now, if we look at this, you can see that these wires come in and they go in underneath this plate and then they come out the other side. Okay? If I pop this plate off, I've got a circuit board here. And the purpose of this circuit board is it's got little switches. I don't know how well you can see it, but there's a cam on this that rises and lowers. So what that does is it's either there's either a magnetic or some sort of a proximity switch, or there's an actual mechanical switch that cam touches. And what that does is it allows the motor to turn so far and then it stops it there. It breaks the connection. And then when you reverse your polarity, the motor goes back the other way so far and stops. That's what allows the motor to turn so far and stop and not go any further. If I just jump the power to the top, what will happen is the motor literally could spin all the way around. So, which I would pose the question, why wouldn't that work? Because if it finds its happy medium and the polarity is going the right way, it's going to still find its path to where it's supposed to be. But we'll pose that for a different day. But that is a fairly disassembled flow valve, and how it works and how to do some general maintenance on it. You can hit stop.